Good day, everyone. Today, we will present our report on curve fitting techniques. Curve fitting helps us find relationships between variables in data, which is very useful in science, business, engineering, and others. Let's begin with part one, the Pearson Correlation Coefficient. This presentation is made possible by the people you see on your screen. In this module, there are three topics this presentation will tackle. Focusing first on the person-moment product correlation, followed by a brief discussion on simple linear regression, and of course, the last is the polynomial interpolation using Lagrange method. So, what is Pearson correlation? The Pearson product moment correlation coefficient, or simply Pearson's R, is a statistical measure that tells us the strength and the direction of the linear relationship between two variables. It helps us answer the question: as one variable increases, does the other also increase or decrease or stay the same? On your screen is the formula for Pearson's R, where R is the correlation coefficient, N is the number of data points, sigma x is the sum of all x values, sigma y is the sum of all y values, sigma xy is the sum of the product of each ordered pair xy, sigma x squared is the sum of squares of all x values. And lastly, sigma y squared is the sum of the squares of all y values. So basically, this formula compares how x and y values vary together versus how they value individually, or as you can see in the denominator. The value of r ranges from -1 to 1, where r is negative is 1, where r is 1, there is a perfect positive correlation. It means that as x increases, y increases. And when r is -1, there is a perfect negative correlation. Or as x increases, y decreases. And there are also instances where r is equals to 0, where it means there is no linear correlation. But remember, correlation does not imply causation. Just because two variables are related doesn't mean one causes the other. Before using persons R, we must ensure that both variables we are trying to compare are quantitative. The data is normally distributed. There are no significant outliers. The relationship is linear, can be checked using a scatter plot or regression line if you want. So simply, to give you an analogy, for perfect and negative correlation, think of it in a perfect correlation, an ice cream sales and temperature. When the temperature goes up, more people buy ice cream. That's a positive correlation. Both go up together. While conversely, there is a negative. The analogy for a negative correlation is, think of it of a video game time and school grades. If you spend more time playing games, your grades might go down. That's a negative correlation. As one goes up, the other goes down. So now let's solve this together. An example, imagine that you are studying the relationship between newborn's weight and length. You have the weights and lengths of 10 babies born last month at your local hospital. After you convert the imperial measurements to metric, you enter the data in a table. Column 1. There are two columns. The first one is the weight, and there is the length. For weight, the data entries are 3.63, 3.02, 3.82, 3.42, 3.59, 2.87, 3.03, 3.46, 3.36, and 3.3, all measured in kilograms. For the column length, 53.1, 49.7, 48.4, 54.2, 54.9, 43.7, 47.2, 45.2, 54.4, and 50.4, all measured in centimeters. Now, these are the values that we need to solve the problem. Calculate the sums of x and y, where x is the weight and y is the length. So the summation of x is equals to 33.5, while the summation of y is 501.2. Next, we calculate the sums of x squared and y squared. For every element in x, square it, then add them all together. Then we get 113.05. Next, for every element in y, square it, then add them all together. We get 25,264. The last value we need is the calculation of the sums of x times y. For each row, multiply x and y, then add them all together. Doing that, we get 1,684.2. Now, for now, take note of those values as we move on to the next slide. Now we get the value. Calculate the correlation coefficient, where the number of data point is 10, and the sum of all x values is 33.5, the sum of all y values is 501.2, the sum of the product of each ordered pair is 1684.2, and the sum of x squared of the sum of the squares of all x values is 113.5. Then the sum of the squares of y values is 25,264. You may use your calculator as after you plug in those values we computed earlier to the formula in order for us to get the r's value. Assume that we have done it. We now get r is equal to 0.47. The result is r is equal to 0.47, and its interpretation is a moderately positive correlation between newborns' weight and length. For the interpretation, you may use or you may refer to other sources you can find online. But today, the interpretation for 0.47 R value is that there is a moderately positive correlation between the newborn's weight and length. That's all for part 1 of this presentation in Module 6. Thank you.